Hello, welcome back to episode 12 of the Cyberbike Project. This is going to be the last episode in this series. Wow, have we come a long way. We've been working on this for nearly 3 months now. We started back in early mid-September, if I believe. I think I'll put a date here when I started. We've got a lot done. The bike isn't complete in its entirety, but it's at a point where I feel it's finished. I've completed all the major technical challenges that I wanted to achieve. The suspension, the front end suspension, the front end steering, the hub-centered steering, the steering geometry up to the handlebars, that's now finished. We've got everything done. The spacing for the batteries, how the form and function of the bike works is done, and that's what I wanted to achieve. The things that are left to do are cosmetic, like, headlights, the seat, foot pegs, finger grips for the brakes. I can spend a couple more months doing all these fiddly bits, but it doesn't make for good content for you guys. And honestly, it's stuff I can do in my own time throughout, the upcoming years to finalize this design, to maybe one day a 3D print a model of it and make a model kit. Maybe, we'll see. It's designed in CAD in full scale, so I would have to either scale down all the components to a form that would be printable, or I would have to redo it from scratch, which is probably what's going to happen with a lot of the parts if I want to go that route. So I don't want to do that just yet. That is a long-term project that'll take a lot of time and effort to get that to work, so it's not really something I'm looking at the moment. But what we have done is a lot of... Now, I've been away for, a while now. It's been over 3 weeks since the last episode. This is for numerous reasons I'm not going to get into, but we're back now. We're getting back into things, and we've done like a whole week of live streaming. I'm live streaming now. If you want to jump in and see what I do and how I work in my workflow in real time, ask questions and chat, you can do that now. Come see me in the live streams. I stream most days starting at 9 a.m. Pacific Standard Time. Come hang out and see how things go. So today's time lapse is a long one. This is a long episode. We've got a lot to cover. I've got a lot of work done. So I will be doing voiceovers throughout the time lapse, and we shall see how that goes. So I'll see you at the end of the time lapse. So, voiceover time, but with face cam. Yeah, get yourself comfortable. I have. We're going to be here a while. This is a lot of footage to go through. I'm doing this voiceover a little bit differently. Normally, I do it inside of Premiere Pro. There's a little button there where you push record voiceover, and it lets you record the voiceover over the footage. But because this is so long, and it's a bit awkward using the Premiere Pro voiceover tool, I'm just doing it this way. So I've got the video playing in front of me on the big screen in VLC, and then I'm recording at the same time with the face cam. We'll just go through it. This was start of last week, Monday, I think. This was one of the live streams that I started. The weekend before, I was on hiatus basically for 2 weeks between the last episode and this episode, and then there was a week this last week where I was working. So over the weekend, I've been, for the previous 2 weeks, I've been trying to work out where to take the bike aesthetically, and work some other stuff out with the steering geometry. That took 2 weeks, basically, among other things. And then over the weekend, I came up with an idea, and I created a new concept sketch for it with more detail. Used my pens. Got a fancy new drawing desk there that my mum bought me for Christmas behind me, and that's a really nice drafting table, drawing desk type thing. So I put it to use, made a new concept art drawing thing. You'll see it pop up somewhere in here. There'll be an image of it, and I'm just using that now as a reference for how I'm going to make this thing styled aesthetically. So I've taken that form that I had over the frame as to represent the tank, and I've basically trestled it. I've cut a whole bunch out, and now I've gone through the frame you just saw before, and created these bolting points around the top of the frame. And now I'm just going to create the corresponding bolts in that trestle on that. I'm calling it the electronics cage, because basically that whole section there, the tank section, is where all the electronics and motor control systems are going to be for the bike if you actually built it, because there's plenty of room in there. This live streaming was fun. I really enjoyed this live streaming. It'll be nice when there's a few more people in the chat. At the moment, I've been sitting there for hours talking to myself, which is loads of fun. What I'm doing here is I'm creating the mounting point for the front suspension, the front shock strut. So basically I need to create an area where the front suspension attaches to, and I don't want it attaching directly to the frame. Same as on the back of the bike, you don't want that sort of thing attaching directly to the frame. You want an intermediate part. If the bike is ever in an accident or a crash, it's easier to replace that section of connective material than it is to replace the entire bike frame. So I've created, on the back you've got all those extra linkages, and now on the front here there's an additional strut section that if there is impact that forces through the strut of the shock, it doesn't apply those forces directly to the frame. There's an intermediate strut section, and that's what I'm creating here. This is the mounting point for it, and then we'll move on to creating that strut. This is it here. Kept it nice and simple, playing around with just different tools throughout this whole project, just trying to up my CAD design skills, playing with the different tools, seeing what shapes and designs I can make. Here I'm using a lot of loft tools and generative design tools after working on the front swing arm. I found that now for the rest of this it's going to be easier to use those generative design tools, and I said this in a previous video, don't use the generative design tools too much. You fall into the trap of not working that stuff out for yourself. But in this case I'm trying to work out ways to utilize it in creative ways. So not just letting it determine what's happening, but using it as a tool, like as it's intended to be used as a tool, and then using that to inform different options that I had. So I've already got ideas of how I want to do something in mind, and then I'm using that to inform me on what the structural aspects of it will be and what directions I can and can't take. So that narrows down the choices that I've made in my mind of what I want to do. You can see here, I'm just doing the stress analysis test. This is way overbuilt, this piece. I ran the stress analysis test before I hock out all the material in it. I'm putting over a ton of force into this thing, and it's not deforming. There's barely any stress deformation whatsoever. It was a beast. So here you can see the generative tool saying, yeah, just hog all this fucking shit out the middle, and there's going to be so much material taken out of it, and that's basically what I did. Come through here, I've adjusted the profile of the two mounting points, which is the mount to the shock and the mount to the frame, and then changing the way that the loft function works between those profiles. See the quick turntable there, how much it actually told me to take off. I didn't want to go that extreme with the material removal, so I've included an extra strut there in the middle, as you'll see now, just to, I mean, it's still way over engineered. Like the amount of force this thing is capable of handling is nuts, because it's basically a 4-pointed triangular trestle. They built the Eiffel Tower using a 4-point triangulated trestle system. They're fucking strong, okay? They build those guide wire towers with 4-pointed triangular trestle systems. They've got proper names. I make up my own names for stuff because, I'm a self-taught engineer. I didn't learn all the proper names, but I understand the concepts of how some of this stuff works. So I've hooked out a bunch of material there, and I've just added these fillets in, and I'm not happy with it. This is one of the reasons why I don't like using the generative design tool, because it tells you like this is the material you remove, and then you have to sit there and figure out how to CAD that material removal in, and quite often you end up with sharp edges or almost impossible to machine shapes. So practicality, yeah, it's not something that's easy to make, and that's generally the problem that you run into. I eventually found a happy medium between if it were manufactured and like it would be a cast piece and then it would be machined. So most of the parts on this bike I've designed so that it starts as a die cast part, and then there's some machining processes to remove material and to clean up reference faces and holes and stuff, threaded holes and stuff like that. And just here, adjusting the overall position so that everything lines up nicely. Now, if you can notice there, on the spring of the shock, so the model that I downloaded from GrabCAD, the spring profile in that thing, you can see it there. Like there's a graphical error in it and it's not filled in properly. I got fed up with this at some stage through this last week, and I actually went into that file, deleted the spring, and used the there's a spring tool in CAD that lets you to do generative design springs based on what forces you want, how much it's allowed to move, how many coils you want, how do you want your ends to look, how thick you want your wire, there's all the options, and you can just tune it in there. And I basically went and replaced the spring, and it's a lot better now. And I've got control over that now, so I can go, okay, I want to see what it looks like with the spring compressed. So I just go in, open up that dialog box, and then I change the value of the length of the spring, and then updates the spring geometry, and then compresses the whole spring because I've got the surfaces mated to the geometry of the spring, so it automatically updates. And that's really handy compared to what I was doing before. It was just a fixed model and I couldn't change anything. Yeah, you can see there I'm going through this list on the side here. Quite often when I'm working, I'll look at what the other options are in drop-down menus, because you'll find a lot of information in there. And one of the things I noticed was there was a screw option or a fastener option that was a flathead cheese screw, I think it was. It had the word cheese in it, and I was like, what the fuck screw is this? So I went and Googled it. Just a regular flathead screw fastener, flathead bolt. But apparently they call it a cheese screw. So yeah, I learned something new there. And there's quite a few of those throughout the week that I've come across. I'll be looking at a name of something in a drop-down box, and I'm like, what the fuck is that? So I just bring up Google and go to Google it. A lot of the stuff that you do is like that. You just have to be curious. Don't just be focused on the thing that you're doing. If you see something you don't know, and you don't have to do this for everything, but while you're working and you just spot something that you go, oh, what is that? Just be curious about it. Go look it up. Take that like 20 seconds to look it up. So here I'm cleaning up the geometry that I used to make the trestles, because I've changed the shape of that front end of the trestle there, where I'm now going to start working on the headstock, which is basically the thing that the handlebars connect to. And in order to do that, I had to change a couple of things and then go back and update, and then I had to update other things because the way I had it designed, it wasn't very good. Here's the concept sketch that I was talking about. Now I've moved the view of my face cam around here, because in the live stream, one of them I had it down the bottom, and then the other one, like this one, I had it up top here. Don't ask me why I changed it. I think it was covering something up, and I wanted to not cover that thing up, so I had it up top for that live stream. Oh yeah, that's right. This live stream, I think I was going to do some video editing on stream, and we never ended up doing that. Or was that this later one? It was a later one. I can't remember what the reason was. There was a reason for why that's up there, or why I'm up here now. I'm covering it up with this cat. Here, have a look at it. Yeah, see? So all of this footage that you're seeing is sped up by 15 times. I could go to 20. It gets a little harder to track and follow what it is I'm doing on screen. 15 I found is like the maximum that I can push this, because I work quite fast myself in real time. If you come and watch on the stream for a while and you see how I work, I'm very snappy with it. It's like these FPS players, so these mobile players, they've got this twitch reaction with their mouses and shit. Like, I don't play a lot of games, so this is my kung fu. This is where I get fast. This is where I get good. And yeah, to then go and do a time lapse on my footage, there's only a maximum limit of how much I can speed it up before it just becomes a blur of unrecognizable stuff. I'm working on the handlebars here. Now, this is one of the big things, like how did I want the handlebars to look? Because there's very little functional constraints to it, because it's not like a regular motorcycle with the shocks, where you've got actual forces of the front wheel and everything traveling up through the shocks into the headstock and then into the frame. The handlebar on this is purely for the rider and for the control of the steering. There's no actual force feedback, proper force feedback coming back from the wheel. There is a bit of force feedback from the steering geometry, but we don't have the amount of forces because we don't have the suspension traveling through the handlebars. So I wasn't as limited with the design constraints on this, so I was like, let's go a bit more aesthetic with this. And that's one of the things I did in that concept sketch. That's the drawing. I'll put a picture up here for you. Is to make something more aesthetic. And it's only a very slight little part of the image where you see it. You have to look at it quite close. It's only a very small detail. But it was enough of a little bit of a small detail for me to develop in my mind the full frame of it, the design of it, from that seed. It blossomed into this whole idea. And it turned out really well. I quite like it. I'm quite happy with it. It started out really chunky, it would have been like this. But I got it down to like this and still kept that sort of chunky feel to it. I wanted that whole cage sort of look on it, and it turned out really nice. I'm very happy. I'm happy with pretty much all of the work that I've done on this bike so far. It's turned out really well. It's turned out better than I expected, and with most of the things that I sit and design, I always feel that pride in my work, and that's why I do it, because you have to have pride like a craftsman in what you do. And you just got to find that passion and work with that passion to do what you're doing. You see here, look how fucking chunky it is. It's ridiculous. It's what happens when you're working in a window with something by itself and you're sort of freestyling what you're doing, and then you pull it into the rest of the assembly with everything else. You go, oh shit, I wasn't paying attention to my sizes and my dimensions. And it's a bit like, ooh, I should change that. There, see there? I'm adjusting the spring size. Surprised I didn't get footage of me actually doing that spring, changing that spring out. But the new spring looks good. It looks much better than the old spring. Spin me right around, yeah. And then I had to go back and change something here again, update stuff. I had to fiddle with that electronics cage quite a few times. It kept giving me grief. I spent quite a bit of time here in this one, just fixing stuff, getting stuff to fit nicely, especially for that the headstock and the way that it all attached to everything. We're at 17 minutes. If you're still watching, I am so thankful. Speaking of being thankful, I have a new Patreon. Very thankful for that. Hopefully there'll be more to come. That was quite a surprise. That's probably why I'm going to be streaming a lot more often. I saw a lot more new people showing up just to see what was going on. I think YouTube's has a different algorithm for showing on people's feeds or whatnot, lives, like people looking at what's live. I think it's got a higher chance of showing up for people. So I'm going to do that more often. I see a lot more traffic into that. I mean, they don't all stay. They're there for like a few minutes to see what the hell's going on. And there's just this weird guy sitting there talking to himself because there's nobody else watching. There's like 1 viewer count, 2 viewer count. For those of you guys that do come sit and watch, for a few hours, or even for 20 minutes, I thank you so much. Like, I really appreciate it. But I'm quite happy to sit there by myself and talk to myself for 3-4 hours. I did one stream that was almost 9 hours with a break in the middle somewhere. Whew, that was a long day. That's why this is so long, this whole video. And this is the final episode of the Cyberbike. Like, I can't believe it. A complete project. This is a first on, the Chaos YouTube channel. I don't think I've ever completed anything in this channel. There used to be a lot more videos in this channel, but I've unlisted them because they were garbage. They were proper garbage. I decided to go with a collet chuck type deal for the handlebars. So the handlebar is going to come to a certain point, and then there's a pipe that you pop into it and you tighten it down, and then your grip and your controls and everything go onto that pipe. So if you drop the bike and you bend or damage the ends of the bars, you don't have to replace the whole assembly, you just replace the ends. So there's another, a design feature that's quite common in some bikes. Most bikes, they actually just have a pipe and it's a separate part. You can drop the bike, that bends, you can just replace that side of the handlebars. Dirt bikes are a bit different, but then again, like, most of the stuff on the dirt bike is designed to be able to come off easily and replaced easily. I mean, the whole handlebar section on a dirt bike, they're cheap. I bought one for my dirt bike once and it was like $16. They're so cheap. And then all the parts and that go onto them. They're designed that when there's a crash, they rotate around the bowl, rotate around the bar, and like push out of the way, so they don't actually damage or bend. It's like just your, I forget what they're called. Your grips? The grips? What are they called? I'm pretty sure they're the grips. The handles? Yeah, those things. So I'm just designing up the collet that goes on there now to tighten those tines up. I was quite happy with the way this turned out. Like, I just sort of freestyled it. This whole handlebar segment, just on stream, all in one go, freestyled it. I didn't have any like proper drawings or anything. It was all just ideas in my head. See how it turns out. Play around with it, and yeah, it was a lot of fun. This was interesting. So I was like, okay, I know that the Autodesk Materials Library has a knurled pattern, like you get knurling on stuff, and then I put it on there, and you can see that the pattern is huge. So I had to go in and duplicate the pattern, duplicate the texture, and then change the scaling of it so that when I applied it, it looked good. I mean, I work in technical sketch illustration most of the time, so I'm not sure why I bother with applying the realistic textures to things. I suppose it's for when I do like the beauty shots or the close-ups and stuff, and then you turn on realistic rendering. You get to see all the different texture profiles. Oh, that was another thing. When did we miss that? I don't think I recorded that. So I remade the front axle that goes in the hub-centered steering, and instead of making it all as like one piece as I did with the previous one, I was like, you know what? I'm going to play around with the welding tools in Autodesk Inventor. So you can create an assembly file that is a weldment file, and you create your individual parts, you assemble them like you do with everything else, but then it's almost like in a regular part file, you add the fillets for the welds, and you can put like all the information: what kind of weld is it, how deep is the bead, is it a penetrating weld, is it just a cosmetic weld? There's all those sort of features you can add to it. So I created the whole axle section, and it's basically the headstock for the rake angle is a cylinder, a solid cylinder with threading on the top and bottom to capture the bearings, and then there's a pipe. It's a hollow pipe, but it's got a cutout through in the middle, and you pop the cylinder in, and there's welds around the top, welds around the bottom, and then on the ends I made 2 end caps, which are machined steel end caps that fit into the swing arm. And you pop them in, put a weld bead around those. And it turned out really nice. It was really, really nice. I just keep saying everything in this looks nice, but, it's not that unbiased, I'm sure. It did turn out nice. I'm sure most of you can agree. I mean, you sit here, if you're still here watching, good on you. Good on you, I'm just waffling on. There you go. There's the Patreon, my first Patreon. It's not in the $1 perk. He's taken the minimum tier, which is the best he can do, which is awesome. But because he's the first patron, I thought I'd commemorate it and just put his name on the bike somewhere. So that's hidden away underneath the steering shock. There's that sketch again. It's a bit of fun using these Copic monikers. Yeah, these ones where my thumb is. Yeah, there. These ones here. I haven't used them really before, so that was my first time using them. It's a bit like watercolors, and I have done a bit of watercoloring, so that was interesting. I quite like them. I need more practice. I'm going to do a few more like sketches and concept sketches and artwork with it. See how it turns out. Alright, so here we go. Now we're going to make the headstock. So this is now going to attach this to the electronics cage. Now I'm eyeing about this, because how much strength did the electronics cage have to hold up the headstock for the handlebar for the rider? I wasn't sure, but it's all 5mm cast aluminum. Like, it's more than strong enough to hold somebody leaning on the handlebars. And especially the way that the trestle geometry is shaped and the way it attaches to the frame, not a problem. I can come back and do stress analysis at some point and show you guys, but trust me, it's fine. And I'm just using an adaptive sketch here. So I'm using projected geometry from the handlebar and projected geometry from the electronics cage to create the angle and the shape, and then I was just going to make a and yeah, it came out alright. I could have fiddled with it for another few hours, but it was good enough. It got the job done. It's only a small part. It's mostly hidden. It's out of the way. What more do you need? Like, it's a basic part. It holds the handlebars on. It's got one job to do. It's amazing what you can get away with the loft tool. I swear to God. The loft tool, eh? I try not to use it for everything, because I could probably use it for everything and everything would look like lofted garbage. If you want something to look good with the loft tool, you have to put the time and effort in to put multiple sketch frames in to loft the shapes better. Because if you just tell it to go from point A to point B, it's just going to go from point A to point B and it's going to look like a lofted garbage. And nobody likes lofted garbage. Alright, finally constraining and attaching the handlebars to the frame. Everything is now officially connected. I also made the axles for, not axles, but like the I think they'd be gudgeon pins? No, not gudgeon pins. I'm not sure what the proper name is. The name for the pins, the axles, the bars that go on the front end parallelogram suspension system. So before they were just constrained. I've actually got axles in there now with holes for bolts and everything, so that's all done. Modifying the brake calipers here, because I need to now make the bolt mounting holes, and I needed some more meat in the back end of it to put the hole for the threaded bolts that are going to hold the caliper to the thing that holds it to the swing arm. And this whole project has been a whole bit of, the leg bone's connected to the knee bone. I don't know. You get what I'm saying. So I'm just making here, this is the rear caliper strut, which is off the rear spacer. Whether that's a good idea or not, I don't know, but it made more sense to do it like this and attach it this way than it did to create another part that came off the swing arm, because then it would have to go past the point of the axle nut and to the swing arm, and around the axle nut, and then all the way to the back to where the caliper is. So it just made more sense to actually make it off the spacing nut, and also the side-to-side face spacing between the central axis of the bike to where the caliper is, to where the swing arm is, like the way everything is all spaced out. It made more sense to come off of that spacer. So the whole way through this that I'm making this thing, I'm just made a stick with two balls on it, and I'm just like, oh my God, this looks terrible. This is on stream, like, yeah, this is fine, this is normal, this is okay, nothing to see here, this is not an issue, nope, nothing to see. This is engineering, this is what we do, like. Oh, it's so bad, it's so bad. It turned out okay, like I did some I did some tricky things with some fillets and chamfers, and it did turn out okay. It still kind of looks what it looks like. It's minimal. It's minimalist, okay? It's very minimalist. It is exactly what you need to get the job done. And then also the braking forces and that from the rear calipers aren't as much as what you'd find on the front calipers. So it's basically made to work. Now, what's happening here? This was fun. So I've created, when I redid the axle for the hub-centered steering, I created the whole hub-centered steering, the hubs, the axle, the swing arms. I did that all in its own assembly file. So now I'm coming in here, I want to work on the steering geometry from the hub center up to the handlebars. But I can't do it because the hub center, like the hubs, are inside a lower assembly file parent in a child file assembly. And you can't manipulate things like that and move them around the constraints when they're in a child directory. So I had to remove everything from that hub-centered steering assembly out and into the main assembly that I'm working on everything, but still kept them in these folders that I've got on the side here, because the list of parts, and I'm going to show you guys a picture of all the parts in this assembly, all the parts for this file, is large. So I had to move everything out. When I did that, all the constraints broke, so I had to go in and go, right, you're attached to this, and then you're attached to that, and you're attached to this. Oh, it just takes forever, especially when you're this far in the project and you've got so many things. We have achieved completion on this project, so it's not so much to worry about. Another big reason for finishing this project now as well is the file is starting to chug. I'm getting a lot of performance loss when working in the file, zooming in on things to constrain stuff, just any kind of work or manipulation on the parts. It just starts to chug the machine, and it's not so much a performance issue of the machine. I think it's a software issue in Inventor itself when you start getting to these large assembly files, because it has to go through and update lists and stuff. And I think it's probably where I've got things constrained and assembled in the assembly file. I'm not doing something completely right, I'm pretty sure. So yeah, it's just becoming more difficult to manage the assembly and work on the assembly at this stage. So it's a good idea to move on to something else. You'll see whenever I'm working on something, I pull it off into a separate window and I work on it by itself, because working on it in the assembly with everything else it's not possible. There's too much lag. So here we're doing the same thing we did as the rear. We're making the struts that hold the calipers. These are also going to double as the mounting points for the steering geometry. So the push rods that do the steering, they come off the sides of this. These are a little bit more beefy because there's a lot more braking forces, because you use your front brakes a lot more on a bike than you do your rear brake. Coming here, making some alterations to the handlebars because I need to create some drop-down tabs to put a hinge assembly in with a linkage that drops down for the steering. And this was so simple. Like, I didn't want to come this route. I wanted to have linkages that came off the back of the handlebar, inside of the electronics cage, came down beside this, the shock, all the way down to, the parallelogram, across the parallelogram, around the swing arm, and then to the front. Like, it's too complicated. it's doable, but you're going to get a lot of backlash through all of those connections, and then managing the levers and the pivots and the push rods all the way up to maintain when you turn the handlebar a certain amount, you turn the wheel a certain amount. It becomes more and more difficult because you have to manage the length of each of those levers that connect to the push rods that translate the forces from the handlebar at the top going like this, and then down to the bottom going up and down like this, and then outward from the swing arm to the side of the swing arm, and then inward going back to the hub, and then pushing forwards and backwards on the hub. Like, I was like, you know what, screw it. I'm just going to drop a linkage down from the handlebars that comes in front of the shock, and then 2 linkages that go out to the sides. Space them out enough so that when you turn, they don't interfere with the tire. And it worked out beautifully. It came out really nice. I was super happy with it. I've got some more footage at the end of it here, because this was the last day of streaming last week, and it doesn't look like this anymore. Like, you'll see it just now when it's finished. Like, I made it basic bitch. I wanted to first validate the idea in my head that these linkages would work in this way, and it wouldn't bind or, you know, interfere with the tire or stuff like that, and it would still work with the suspension when the suspension operates. So I just mocked up the first linkage, and then the second linkage, the linkages on the side, I created these ball joints previously, and I just attached them in, and I didn't even create the bar that goes between the ball joints. I just used a constraint and pushed the constraint measurement, measured the distance from point A to point B, and then constrained the face of the one ball joint to the other ball joint around the circular constraint, so that they didn't move closer, further away, and they didn't change their axial orientation from each other, so they stayed locked to each other as if there was a bar there. And that's just a quick trick that you can do when you're prototyping stuff, so that you don't have to spend all the time making the geometry before you just need to validate that the thing is going to work. And especially when you're making complex mechanical stuff like this, you need to validate that it works before you spend the time and energy making the thing only for it to not be useful. So yeah, I'm attaching these ball joints, and again, made the ball joints with the ball all in its own assembly. But when you bring it in here, you can't have that ball moving inside that assembly on this assembly. So I removed the ball from that small assembly, put the ball in this assembly, and then just attached that assembly to the ball so that it would still rotate around the ball. And there, you can see there, I've attached one to the hub and one to that linkage that's dropping down from the handlebars. Now I've only got one on the one side, and I tried turning the handlebars and it didn't work. And of course it won't work, because you're only pushing on the one side. If you turn that, it's just going to move away from wherever the linkage is. Like, it'll twitch the wheel a bit, but it won't. So you need to put the other one on the other side. And it creates a perpendicular frame constraint, because you've got a fixed frame at the bottom and you've got a fixed frame at the top. And then that was basically all that I got done for those streams. And then this section where after I've created those constraints and validated that push rod system would work, I've come in later on and cleaned up the linkage and made it look pretty and stuff. So this was all done off stream. I did this morning. Took me like an hour's work, less than an hour's work. Just to clean it up, make it pretty, extend the bottom section where the push rods join up to, and yeah, that's it. It's all done. What more can I say? This has been a journey. One hell of a journey. You guys, if you're still watching, fucking good on you. Thank you so much. I really appreciate it. There was a lot to go through there. It's a long video. I won't be making a long video like this again. I will get my act together. I promise. But yeah, so yeah, there she is in all of her glory. Made that nice little turntable render for you guys. You saw that on Twitter. Uploaded that to Twitter. That's all of it. And we're gonna get into the next project in the next episode, and that's gonna be interesting. And interesting for a number of reasons, because as some of you that have been following along on the stream have heard, the next project is going to be a RC airplane, a bush plane, a short takeoff and landing plane. And we will get into the details of that in the first episode of the next series, which is going to be the Draco bush plane. So, yeah. I've been Chaos, and this has been the Cyberbike Project. I hope you guys have enjoyed. If you're still watching, thank you so much. For my patron, thank you very much. I really appreciate it. And hopefully there'll be more in the future. I'm Chaos, and as always, expect the unexpected. See you guys next time.